And action. Hello and welcome back to Calculus 1. The next section is 3.5, derivatives of trigonometric functions. So we can prove these using the limit definition, right? For the honors college, for honors students in mathematics, that is something that is on the exam. The proofs for these, I'm going to do proof for sine only, so you can have some idea of how these proofs look like. You can do proofs for all of them. They're not going to be part of our exam because it's not another section, but you must memorize the 6 formulas for derivatives, because those 6 formulas will be read backwards for integrals. And then there will be quite a few sections that will utilize these in Calc 2, differential equations, and so on. So your future education depends on you memorizing these as soon as possible. And then once we learn derivatives of trigonometric functions, we can go and use product rule, quotient rule, and everything else that we are going to learn later with trig functions. We know that trig functions are periodic functions. They model different types of phenomena than polynomials and so on. So they're very useful. And we would like to measure the change using trig. So we are going to now define the derivatives for all of them. So I'm going to write all 6 formulas first, and then I'm going to prove sine. We do a few examples, and we are done. Sounds simple, right? I mean, it is. So the derivative of sine x is anyone?
0.
No. Cosine, thank you. I'm just trying to see who did class prep and pay attention, that's all. The derivative of cosine x is negative sine x. Good. The derivative of tangent x is secant squared x. Guys, focus, focus. The derivative of cotangent x is negative cosecant squared x. Yes? All right. So the next is the derivative of secant x, which is secant x tangent x. And the last one is the derivative of cosecant x, which is negative cosecant x cotangent x. There is an amazing way to memorize this because these formulas are highly symmetric. First of all, we are going to notice that you have trig pairs. So these are calc trig pairs. Sine with cosine, secant with tangent, and cosecant with cotangent. If you look at any of the formulas, you will always see those pairs appear. You will never see sine with secant. You will never see sine with tangent. You will only see sine and cosine with sine. You will only see secant with tangent and tangent with secant. Yeah, there is a secant squared, but that's still secant. So if you observe these formulas, that pairing is 100% followed throughout all of them. Next, sine, cosine, negative sine. Those kind of look kind of flipped, right? But look at the tangent and cotangent. Secant squared, cosecant squared, right? And then look at the secant and cosecant. Secant tangent, cosecant cotangent, right? You see how in pairs they appear to be the same, right? Now look at all of the derivative of co function. Are they all negative, right? The cosine, the cotangent, right? So all of the co, right, are negative. This is highly symmetric, and it is going to take you, writing these formulas a few times, but it is very, very quick to remember them. Another way that for some of you visually this might make more sense is to put every other formula on the right. So move the cosine here and move the cotangent here, right? So you see them side by side. You will see how all of these that you write here are negative. You will see that they have the same form if you go this way. It's very easy if you think about it, focus. It is very easy to memorize all of these formulas. So these are your derivatives. Now all of these derivatives can be derived and proven by using the limit definition of the derivative. And the limit definition of the derivative tend to be a little bit hard to work with for this case, but it's possible. And there are much better proofs for this in Calculus 2 when you hit power series in chapter 9. We can prove many of these in much better way than the limit definition. But let's take a look at the proof of sine, and then we'll work out a few exercises that involve product rule and quotient rule, and then move along. So proof for derivative of sine x is cosine x. And the way it's done is we use the limit as h goes to 0 of sine of x plus h minus sine x divided by h. The only thing that you can do in this case is to use the sum formula to expand this part. So that's going to be limit h goes to 0 of sine x cosine h plus cosine x sine h minus sine x divided by h. I am going to group the first and the last term and factor out sine. So I will have limit h goes to 0 sine x of cosine h minus 1, and then we have plus cosine x sine h, all of this divided by h. I am going to use the limit laws to separate this, because I have addition, it creates two fractions, and then each one gets its own limit, and then I have multiplication within each one of these, which gets its own limit. So I'm going to have limit h goes to 0 of sine x times limit h goes to 0 of cosine h minus 1 over h plus limit h goes to 0 of cosine x, I don't have room, times limit h goes to 0 of sine h over h. So these limits are, the first limits of sine x is just sine x, because the limit is h goes to 0 and there's no h here, so it's like limit of a constant, it's just that number. This limit here goes to 0, so it's times 0, plus we have just a cosine x times, and this limit goes to 1. So it's 0 plus cosine, which is cosine. Now you can do this for all other trig functions. This is just the outline of the proof for the first one. And it depends on you knowing these limits, which are a little bit difficult, that this one is equal to 0 and this one is equal to 1. So if you want to challenge yourself, if you're thinking about becoming a math major or doing something more significant later with mathematics, you might want to look into these proofs because they have a lot of cool features. our business, our job here is to take a look at mechanics of calculating trigonometric derivatives. And mainly we are looking into the product and the quotient rule because apart from derivative of secant is secant tangent, there's nothing else you can do there. So we look into x squared sine x as the first example for you to work out. So what do you get? Is the string going? Yes, perfect. Guys, are you getting these job flash emails? Yeah, there's like 50 jobs there. I don't know, maybe to forward or something? Maybe they're suggesting something. All right. Calc 2, you're on your own, guys. Let me see. There is assembler. Matrix controls. Oh, definitely does. You have no idea. I ran calculations. Plumbers make about twice as much as I do. About. Electricians are pushing maybe even 3 times more. I ran when I take my yearly salary without the extra classes I teach, and I run it down to per hour, with all the extra stuff that I do with clubs and so on. Yeah. So if you're going for the money, you should be doing your plumbing licenses and electrical licenses and HVAC licenses. That's where the money is. All right. I know someone who bought the restaurant 1.6 million for cash. Guy's a contractor. So yeah.
That's what made me want to become an engineer.
Yeah. Engineering is going to give you a pride that you built something that doesn't exist. You know, iPhone 10.
iPhone 10.
Garbage.
See you in August.
Nice. So what kind of the derivative we have to do here?
Wait, I just did say see you in August.
Yeah. We stream. High stream.
No, but the test don't test.
Or maybe 2 weeks.
Oh, dude, being sarcastic. No.
Thank you for your concern.
Yeah.
Copy the first derivative of the second plus copy the second derivative of the first. Just keep going.
So you factored out that X?
Oh, I did factor that X. Right there.
I got the first one.
Like a boss.
Like a boss. So question, when you factored out that X, that's my 10. Yeah.
let's take a look at more of these exercises. So here are, this is problem 22 in a textbook. So the derivative of e to the 6x times sine x.
Sine of x is e, so sine x. I'm a genius.
And you
I love
factor out, yeah. You factor out e to the 6 plus, with the 6 stuff of that plus. I think that we close down the together. That is it.
Yeah.
So for the e, I know the 6 comes down.
Good.
Well, why the hell is 6x still up there? That's
It
a
stays
couple
there.
of them. It does?
Yeah.
Because it has an x?
No, that's the argument of e. It stays there.
it
The
stays
whole
there.
exponent stays there. Yep.
Okay.
So this is another product rule. Yeah, I'm glad you're paying attention.
I'm paying attention.
So copy the first times derivative of the second plus copy the second times derivative of the first, which is e to the 6e to the 6x. Factor out what can. And there it is. One more example from textbook. Problem 28. You're going to love this one. It says x sine x divided by 1 plus cosine x.
Oh wait, this is a question. So, since I have x and sine x, how do I incorporate the product rule and
Like this.
find that first? Oh, true. So then, so,
So this is another one of those problems where you have to do product rule within the quotient, right? So to do the quotient rule, we are going to take denominator and place it in denominator squared. Then we copy as is. And then derivative of the numerator is the product rule, right? So copy first, derivative of the second plus copy the second times derivative of the first is 1. So we don't need to do anything there. And then we have minus, copy the top, which is x sine x. Did that calc too?
You shouldn't be laughing.
Yeah, they won't be laughing soon.
We're probably just laughing at the
No, it's not done.
Oh, it's not done. So now we're going to FOIL, which is x cosine x plus sine x plus x cosine squared x plus sine x cosine x, and then plus x sine squared x. There we go. So just a little bit of algebra. Nothing major. And this is some cool stuff that we recognize because it's a trig, right? This term and this term, if you factor out x, you get sine squared plus cosine squared. So those two terms will give you x, actually. And the rest of the terms you just have to pile up. So I have x cosine x plus sine x plus sine x cosine x, and then we have just plus x, because, and I'll just put the little check mark above so you know that those two terms came from there, divided by 1 plus cosine x squared. There is really nothing else we can do that would be significant here. Well, actually, wait. We can factor out x and have 1 plus cosine x and factor out sine. Ooh, look at that. And you get 1 plus cosine x. This actually works really nice. 1 plus cosine x squared. You can factor out 1 plus cosine x and get x plus sine x and cancel one of the ones in the denominator. This is really cool. I like this problem. You put this one on the final, right? There we go. Wow, this worked really nice. Hell no. Yeah, but you have this plus 1 that... Yep. The last thing that I want to say here in this section, these poor souls left so they will never know, is, you remember how we covered the formula for e to the x when we said that the derivative of e to the x is e to the x? But I also gave you that other formula that allows you to have e to the ax, and then you get a e to the ax. So exponent always gets copied the way it is. You have the same happening for trig. So for trig, if I write derivative of sine ax, that a is going to float in front and become cosine ax. Same. So if you have the derivative of cosecant ax, you can fix all 6 formulas with this. It's going to be negative a cosecant ax cotangent ax. So you can fix all of the other formulas with this. I'm just going to work out one exercise so it kind of has the example attached to it. We're going to cover a rule called chain rule next week, and that or maybe next class, depending on how fast we move. So that rule will have a lot of will override kind of this thing. And so let's say you are taking the derivative of secant 5x. You know derivative of secant is secant tangent, So this is secant 5x tangent 5x, and you have to put 5 in front, as that's that 8 that floats in front. Now you will learn that that 5 that goes in front is actually something that we call chain rule, and that will be studied, I believe, in 3.7. We are now at 3.5. Oh, so it is next class, right? So next class, 3.6 and 3.7 definitely. We'll see if we can peek into 3.8.
We can talk about in the lab.
So the lab or test. Okay, let's talk about, let me just end this. So by stream.